Good morning, I am Devasena. In this lecture, we are going to discuss about voltage and current division. This topic is present in the subject circuit analysis and circuit theory. Consider a series circuit of two resistors R1 and R2 connected to a source of V volts. This is the representation of a series circuit. In this circuit, we are having a voltage source V and resistors R1 and R2 is connected in series with the voltage source, and current I is flowing in this circuit. As two resistors are connected in series, the current flowing through both the resistors are same, that is I. Then applying KVL, we get capital V is equal to I into R1 plus I into R1 R2. Consider this as equation 1. That is, the value of current I is equal to capital V divided by R1 plus R2. Total voltage applied is equal to the sum of voltage drops V suffix R1 and V suffix R2 across the resistors R1 and R2 respectively. That is, V suffix R1, that is the voltage drop across the resistor R1 is I into R1. Consider this as equation 3. Now substitute equation 2 in equation 3. We get capital V suffix R1 is equal to V divided by R1 plus R2 into R1. That is equal to R1 divided by R1 plus R2 into capital V. Consider this as equation 4. Similarly, the voltage drop across the resistor R2 is V suffix R2. Its value is V suffix R2 is equal to I into R2. Consider this is equation 5. Therefore, V suffix R2 is equal to V divided by R1 plus R2 into R2. That is R2 divided by R1 plus R2 into capital V. Consider this as equation 6. So, in general, voltage drop across any resistor or any combination of resistors in a series circuit is equal to the ratio of that resistance value to the total resistance multiplied by the source voltage. For AC circuits, the result is applicable with resistance getting replaced by impedances. That is, V suffix Z1 is equal to V divided by Z1 plus Z2 into Z1. That is equal to Z1 divided by Z1 plus Z2 into V. Similarly, V suffix Z2 is equal to capital V divided by Z1 plus Z2 into Z2. That is Z2 divided by Z1 plus Z2 into capital V. Now we discuss about current division in parallel circuit of resistors. Consider a parallel circuit of two resistors capital R1 and capital R2 connected across a source of capital V volts. This is the representation of two resistors R1 and R2 connected in parallel with the voltage source. Current through R1 is I1 and R2 is I2, while total current drawn from the source is I suffix T. Therefore, I suffix T is equal to I1 plus I2. Consider this is equation 1. But the value of I1 is equal to V divided by R1 and value of I2 is equal to V divided by R2. That is, V is equal to I1 R1, that is equal to I2 R2. Consider this is equation 2. Therefore, the value of I1 is equal to I2 into R2 divided by R1. Consider this is equation 3. Substituting the value of I1 from equation 3 in IT, that is in equation 1, we get I suffix t is equal to I2 into R2 divided by R1 plus I2. Consider this as equation 4. That is IT is equal to IT into R2 by R1 plus 1. That is I2 into R1 plus R2 divided by R1. Consider this is equation 5. Therefore, the value of I2 is equal to IT into R1 divided by R1 plus R2. Consider this is equation 6. Now, I1 is equal to I suffix t minus I2. That is simplifying equation 1. So, the value of I suffix 1 is equal to I suffix t minus I suffix t into R1 divided by R1 plus R2, because the value of I suffix t is substituted from equation 6. So, the value of I1 is equal to I suffix t into R1 plus R2 minus R1 divided by R1. So, I1 is equal to I suffix t into R2 divided by R1 plus R2. Consider this is equation 7. In general, the current in any branch is equal to the ratio of opposite resistance to the total resistance value multiplied by the total current in the circuit.